Hi everyone! What a beautiful day to all of us. So this time we're going to talk about systems of linear inequalities into variables. So let's proceed. So with this, let's say you're expected to explain how to solve systems of linear inequalities into variables. This is just an example. So we're going to answer this, okay? You will learn how to explain, you will learn how to graph systems of linear inequalities into variables. Let's start. So how to solve? Here it is. Example, we have y is less than 2, x is greater than or equal to negative 1, and y is greater than x minus 2. So in here, so we're going to graph all three inequalities in the same coordinate plane. Okay, all these three. The graph of the system is the overlap or intersection of the three half planes. So shown, here it is. Okay, so this is the graph. As you can see, we have three graphs of linear inequalities. So we have the first one, y is equal to 2. It is broken line because it uses the symbol is less than. Okay, and then another one is x is equal to negative 1. Okay, that is the vertical line, and a solid line, and lastly the diagonal line y is equal to x minus 2. Okay, and as you can see, there is the overlapping shades, okay, of the three inequalities, and that region, which is triangular one, will be the solutions. Okay, all the points lying on the shaded region are the solutions to the inequality system of linear inequalities. Okay, example is 2 and 1. Let's use that point, the 2 and 1, and then we're going to substitute that to the three inequalities, and it will give us true statement. So that is the solution of system of linear inequalities, a point or an ordered pair that will satisfy all three of them. Okay, if only two can are satisfied in the given coordinates or points, then there is not solution. It is required that a solution, a point, or the coordinates must satisfy all three of them. Okay, let's proceed with my own example. Here it is. So let's graph the system of linear inequalities given 2x plus y is greater than or equal to negative 4 and x minus 2y is less than 4. So first thing is we're going to find x and y intercepts, okay, of the two inequalities. So let's say 2x plus y equals negative 4. That's the first thing, okay? Rewrite the inequality into an equation, the equivalent equation. Then for us to get the x and y intercept, so substitute 0 to get the value of y. So we have 0 and negative 4 as our first point to the first equation, first inequality, and then the value of x will be negative 2 and 0. So we have 0, negative 4, and negative 2, 0 as x and y intercepts of the first inequality. And for the second inequality, x minus 2y equals 4, we have 0, negative 2, and 4, 0. So we're going to graph this. Okay, again, after finding the x and y intercepts, graph. Okay, graph the two inequalities. So let's graph it now. 0, negative 4, and negative 2, 0. So that is 0, negative 4. How about negative 2, 0? Okay, that's it. And then, what line are we going to use? Okay, we're going to use solid line since the symbol used is greater than or equal to. And then, what are we going to shade? Is it the upper side of the line or the lower side? So, yes, what we're going to do next is to do a testing point or point testing. So as for me again, I love to use 0, 0. So if I substitute 0, 0 to the first inequality, it will give me 0 is greater than or equal to negative 4, and that is true. So therefore, I'm gonna shade the part where 0 located is 0, 0 located is. So that is the upper part. So let's shade the upper part, And then for the next inequality, 0, negative 2. Okay, and then 4, 0. That's it. Then we're going to use broken line since we use less than symbol. Okay, and after this test point again, if I use 0, 0, so it will give me 0 is less than 4, which is correct. So therefore, I'm going to shade the upper part. Okay, so with this, the overlapping region of the two inequalities will be our solution set. Okay, the graph of the system is the overlap or intersection of the two half planes. So with that, we can give solutions. Okay, let's say this. Give at least three solutions to the system. So it can be 0, 0, 1, 0, 0, 2, and 3, 2. Oh, where are they located? 0, 0, 1, 0, 0, 2, 3, 2, and etc. Okay, all the points lying in that overlapping or intersection part of the two half planes are all solutions to the system of linear inequalities. So that's it. That's how easy graphing or solving system of linear inequalities. I hope you learned from this slide. Thank you very much. So also additional, so if you're asked to identify 3 points, the same. You just need to graph the two inequalities in one coordinate plane, and then you'll be able to identify 3 points that belong to the solution set. Okay, the same with what we did before. Then this one, you will be able to explain why the system of linear inequalities has no solution by graphing it again. So as you graph, then you can see that there is no intersection or overlapping region. So that's the reason. That's why there is no solution. Okay. Another is this one, last one. True or false? The solution of system of linear inequalities is an ordered pair that is a solution of any one of the inequalities in the system. Is it true or false that any one of the inequalities in the system? That's not true. Okay, so I said the answer. It is not true. Why? It is required for an ordered pair to satisfy both of the inequalities, not just any one. Okay? Both of the inequalities. So that's all, and thank you very much. I hope you learned from this slide, from this session. God bless us all.